Alright, let's go over the Unit 0 Quiz Review Worksheet. Number 1. You notice after riding on an airplane that your sealed bag of potato chips got all puffed up once you're at a higher altitude. Using what you know about gas behavior, explain. So here's the bag of chips. Here's a bunch of chips in here. And then here are the gas particles. Apparently this bag has very few chips. There are also gas particles outside the bag. So this is at sea level, like if you were eating potato chips at your house right now. Okay, unopened bag. When you take this bag up in the airplane, it puffs up a little bit. Okay, same chips, same amount of gas particles inside. So the difference is now there are less particles outside the bag. So now the particles inside are like, woohoo! We're winning, we can push out a little bit easier. Kind of like when we had the balloon in the bell jar and we reduced the pressure inside and the balloon got really big. Number 2, if you're converting from Kelvin into Celsius, then you want to use the one that solves for Celsius. So we want to do K, which is 160, minus 273. That comes out to be minus 113 degrees Celsius. If you've got Celsius and you want to get it into Kelvin, add 273 using the other formula. You do not have to memorize those formulas, they'll be given to you. Then we've got all the different relationships. Volume and pressure. Let's start with that. If you've got a syringe and the particles have a certain amount of space, but then all of a sudden you give the particles more space to move around, like now they have this whole area, they're not going to collide as often with the walls of the syringe. And I should note there should be the same number of particles in each of these. It looks like I drew more. I wasn't counting. Okay, so let's think about it the other way. What if you decrease the volume in this syringe and you give the particles barely any space to move around? Now they're going to be colliding a lot more frequently. The pressure's going to go way up. So since the pressure goes up when the volume goes down, those are opposites, and that's an inverse relationship. I'm going to try and write this out in words too. As volume goes up, we'll do it this way, pressure goes down because particles have more space to move around. So they collide less. Thus, less pressure. Oops, this means this is less here. As volume goes up, the pressure goes down because the particles have more space to move around, so they collide less. What about temperature and pressure? Okay, what if you've got a sealed container? I'll just draw 5 particles. And you light a fire underneath this. The particles are going to start moving faster and faster. So they're going to be colliding with the walls more frequently, therefore exerting more force on those walls, and that's a higher amount of pressure. So as temperature goes up, pressure goes up. That relationship is direct, since they're both going up. So I'll explain that again. As temperature goes up, pressure goes up, because as particles speed up, they collide more often, thus increasing the pressure. For temperature and volume, imagine the balloon. So you've got the balloon here. Okay? If those particles are heated up, like maybe you have a hairdryer pointed at it, that balloon is going to get bigger because now those particles are moving faster, and so they're able to exert more force on those walls until they reach that point where the balloon has grown, and then pressure will be constant. So as temperature goes up, the volume goes up of a gas, and that is a direct relationship as well. I'll explain it over here again. As temperature goes up, volume goes up because particles move faster, and if you've got a flexible wall for like the balloon, for example, they can push on those walls more. And then our last one, how about the effect of the number of gas particles on pressure? If you've got a box with 5 particles and you've got the same size box with 10 particles, which one of those is going to have a higher pressure? Well, this one, because there's more things colliding with the edges of this box. So as the number of gas particles goes up, the pressure goes up. Another direct relationship. As number particles increases, pressure increases because there are now more collisions. Alright, moving on to the back. KMT, you can find this in your skeleton notes that we took on the second day of class. It stands for Kinetic Molecular Theory. Kinetic means movement. So the components are talking about the behavior of gases and properties. Gases take up space. They can be compressed. Gas particles move in straight lines. They change directions when they hit something. Gas particles move constantly and randomly. Gas particles bounce off walls and exert pressure. Pressure is the force exerted per unit area. And when temperature goes up, the speed of particles also goes up. Number 5. What must have happened to the volume of the container if the pressure went up? Well, let's think about it. Okay, so we've got this 24-liter container. If the volume had gone down, they have a lot less space to move, so they're going to be colliding a lot more. The pressure here is going to be much higher. If the volume had grown to more than 24 liters, now those particles have more space to move around, so the pressure would go down. So the answer should be less than 24 liters. Alright, last problem. You're supposed to label this graph. The manipulated variable goes on the X. The responding variable goes on the Y. A great title is always the effect of the manipulated variable on the responding variable. Second to last problem, I guess. Let's check out this conclusion. They have a claim. As temperature goes up, pressure goes up. They have evidence where they cited data. When the temperature was 4 degrees, the pressure was only 86 kPa. But when the temperature went up to 44 degrees Celsius, the pressure went up also, 182.9. That makes sense because as pressure goes up, or the pressure goes up when the temperature goes up. So they didn't explain what the gas particles were doing. They forgot their reasoning section. They should have said something like, this data makes sense because as temperature increases, particles speed up and collide more, thus increasing pressure. I want to remind you that you should really go over all of the demos that we've done in class, and there is a great resource for you. If you go to Brightspace and you search under content and you actually go to the notes section, you can watch YouTubes of, this is the lecture that you may want to revisit, the bell jar demos, the skinny egg demo. There's the crush the can demo somewhere in here as well. Might be in on the first one. Yep. Down here hiding. There's a great simulation to do. I really recommend it. It's kind of like a game. It's fun. And then there's also some extra review from a different year. So there's lots of different resources on here besides the answer key. So if you need extra help, you can always come in before or after